Hi everyone, Chica here with Sir Dojo, and in today's video we're going to be discussing number systems or notational systems. So we're going to be delving into the differences between binary, hexadecimal, and decimal. If you're going to be an IT professional, it is important for you to understand these number systems because you're going to encounter it when you get into things like network configuration and overall just general data representation. While you and I grew up counting from 1 to 10, computers operate a little bit differently because they use a completely separate number system. Binary is the building block for all computer data storage and operations. The binary number system only uses 2 digits, 0 representing off or false, or 1 representing true or on. This is because computers are electrical, so if we're talking about electricity, then light can only be on or off. Binary notation then is what we refer to as base 2. Now before we delve deeper into binary, let's go ahead and clear up the decimal number system. Decimal is the most common number system because this is what you're using in everyday life. Now, all major number systems in the world are positional. This means that the value of the number is determined by where it appears. We call this the place value, and this determines the magnitude of the number. So if we use this number here on the screen as an example, and you were asked to name this number, then you would almost innately say 5,901. And this is because you already know the number system. You already are familiar with the decimal number system. If we think way back in grade school or primary school, you were taught different positions for the numbers depending on what you're trying to represent. So there's a thousands place, a hundreds place, a tens place, a ones place, and so on. The ones place is 10 to the 0. The tens place is 10 to the 1. The hundreds place is 10 squared. The thousands place is 10 to the third, and so on. So for the CompTIA exam, understand that the decimal number system then is base 10. The characters can only be represented 0 through 9. So that's 10 digits. It's base 10. It's 10 raised to the power. So when we get back to binary again is base 2. And you can only represent the values in ones or zeros. So the numbers that you're looking at here, the top number is a decimal number. And I have it represented as base 10 here so that you know that this is a decimal number. When it comes to binary, you can represent binary numbers by using base 2 as I have it here. Now, the difference in how you may be calling this number here, because it is binary, then it is not 1010. Because again, it's a binary number. This is not a decimal number. So this number here is 1010. Now, I'm not going to delve into how to convert between these number systems in today's video. I really just want to focus on you understanding what they actually are. But understand that when you see a binary number, it's going to have a decimal equivalent. So 1010 in binary would be the equivalent to 10 as a decimal number. There is another number system that is not listed on the CompTIA objectives, and that is called Octal. And Octal is base 8. However, we're not going to cover that because it's not listed on the objectives list. So get familiar with the term Octal if you hear it. However, you most likely are going to be studying this for the CompTIA Network Plus, not so much for the IT Fundamentals or the A+ exam. Octal, being base 8, is its own number systems with its own rules. We're just not going to cover that here in this video. As time progressed, we needed a better way to store more information. And this is really where hexadecimal comes in. When we're talking about hexadecimal, we're talking about base 16. Hexadecimal is a little bit strange compared to the other number systems that we were discussing. And this is because we now have letters included. So hexadecimal characters are represented in numbers 0 through 9 and then A through F, and that is 16 digits. Hexadecimal numbers can be represented in a couple of different ways. So they can be separated with dashes, colons, or sometimes periods. Let's go ahead and wrap up today's video by clarifying why we're using different number systems in the first place. We use different number systems because each has their own purpose. The decimal number system is the most familiar, so it is going to be used by most cultures on Earth. Right? Base 10, we got 10 fingers. It's fairly easy to use that one to count. Computers are electrical, so they're either on or off. So when they are receiving or sending pulses, then they're going to be using binary. The hexadecimal number system, being slightly newer, also serves its purpose because we can store more information using less characters. This makes it easier for us to read certain values such as MAC addresses or IP version 6 addresses. In closing, understand that each notational system serves a particular purpose. Binary base 2 is represented in zeros or ones, and that is what the computer uses by default. Human beings use the decimal number system. That is base 10 and the digits are 0 through 9. And finally, when it comes to hexadecimal, hexadecimal is base 16, so that's 16 different characters. So that is 0 through 9 and A through F. If you appreciate the content, please give us a like, share, and subscribe, and comment if you have any questions. We'd love to hear from you.